Matt, for the introduction. I'd also just like to point out that the lights aren't that bright, so everyone else who was up here before, I don't know what their problem was, but I can see all of your faces smiling at me, and I love it. So I'm Dave Panny. I'm an incident response and forensics consultant. I'm a Python hobbyist. The tool we're talking about today is written in Python. Not a Python expert, so if it is, quirky or weird, just letting you know that up front. Is my GitHub link, and there will be some more information about that later. I also am a self-described curator of bespoke and artisan artifacts. I like to find new things. The talk that I am following is really difficult to follow because that was really awesome. I like to see all kinds of interesting things like that, weird parsing and all kinds of interesting things. I'm also quite fond of not just payment card breaches, but investigating them. I think they're a lot of fun. And my time as an incident responder, I've had some great examples and great experiences tracking down financially motivated attack groups, trying to find the credit card data that they've stolen and trying to see if we can figure out how much data they've stolen. That's my Twitter handle as well. Not David Panny. I'm not a lawyer, so I cannot give you any legal advice about what to do if you have a credit card breach. Not a PFI, a PCI forensic investigator, not a QSA. You may be thinking, well, Dave, why are you up there? I can't answer that question either. And I'm also not responsible for any errors that occur. Like if my tool does count something wrong, I'm more than happy to help you troubleshoot it, but please don't sue me. I don't want to do that, and my employer doesn't want to be responsible for that either. So who dat? What are we talking about with CDPO? The credit card data processor and organizer. Throughout the next 30 minutes, we're going to talk about what magnetic track data looks like on a credit card, an example of how we use credit cards to buy things and what that looks like a little bit on the back end, and also example of how attackers steal this information and then how we find out what they've stolen. We'll talk about the old way to do it, and then we'll talk about the new way, the CDPO way, and give you a little demo. So that's what we're going to talk about today. What does magnetic track data look like? I had that hard drive on there when I think at a forensics conference. When we think about magnets, that's kind of what we're thinking of, so we got rid of that. When you look at a magnetic track data on your credit card, it's just a black strip. You may think, what the heck is that? But when you swipe it, the special readers can pull this type of information off of it. You'll see track 1 and track 2 on there. They should be on pretty much every credit card. Track 1, the big difference is it has a name. We'll look at what the other information is. Track 3, I've heard it exists, never seen it. And a fun fact, we were trying to determine if malware was effectively capturing credit card numbers one time, and I saw this in the output file, so I reached into my wallet, and I said, man, that does look like my credit card number. This is some pretty good malware. And I did find my own stuff, and then all my coworkers were like, hey, can you see if my name's in there too? It was kind of fun, kind of terrifying, and a lot of evil responsibility to have. But these are the things you may come across when you're investigating a credit card breach. Now I do just kind of feel like this guy, the LifeLock guy who put his social security number on the billboard. You all saw a credit card number of mine, but it's expired and it wasn't real anyway, so I don't really feel that bad. But I thought it'd be a fun slide. So let's look at break down track data. This is track 1. It has our name. Highlighted in orange, it'll be our primary account number. That's the number on the front of your card. Highlighted in blue there is going to be my name. And highlighted in green is going to be the expiration date in year, month format. Track 2 will be the exact same, except some of the delimiters at the beginning and the end will be different. And instead of a caret name, caret, it'll just have an equal sign. This is all the information you need to make, partially this is the information you need to generate a fake credit card or to make a transaction, along with the less interesting data, such as the security code. Fun fact, the security code on the magnet is different than the security code printed on the back of your card, so those won't line up. And that's how your bank knows if it was a card present or a card not present transaction, which I thought was interesting to learn. But that's the other stuff there. Everything after the expiration date is kind of discretionary to the card brand and the bank, and they may put different things and they may be different length levels. And I think I had a link to a Wikipedia page, which is where I do all my research, so my high school teachers are very disappointed in me. So when you buy something, you swipe your card, goes on that cool little reader, it decodes the data that we just looked at, sends that into the POS terminal, which is running Windows, Linux, iPad, whatever it is, sends that in there in clear text, usually by the way, And then the POS application will send that to the bank and say, hey, look, I have this, this track data. Can you please validate it? Make sure the credit limit has enough to make this purchase. For me and my black card, I never get declined. It's great, but oh wait, that's not me. But this is how it works. Important to keep in mind that on most systems by default, the card reader, when you swipe it, does not encrypt the data. It just sends it in clear text as you just saw it to the POS application. There are third-party solutions that when you make a transaction, it will encrypt it right at the reader, and from then on, it's difficult for an attacker to steal and decrypt. But when it's not encrypted, it's easier for the attacker to get. So that's what it looks like when you make a purchase. Let's see, what happens, how an attacker exploits that. They will put like card scraping malware on a POS system, which is just going to process the memory and keep scanning and scanning and scanning, looking for a regular expression that matches that track data format that we looked about, either track 1 or track 2, probably both. They want to grab all the tracks on tracks on tracks. We've seen certain card scrapers that'll just tear up all the memory. Some of them will be focused on a specific application memory. There are different POS applications. They'll just be scanning the memory sections of that executable. So they'll run a regex. Some of them may do some validation, some might not. And then the interesting thing is that, what the attacker has to do is they have to get this credit card data out of the memory and into a file or a registry key, or maybe they'll send it to an aggregation server somewhere. But as an investigator, we need to find where that output file is, because that's what we're trying to count. And it's likely encoded. I haven't seen many credit card scraping malware like just write it out in clear text. So everyone who runs the default end case like credit card or PAN or track data regex and gets 4 million false positives and has never found anything good, probably not going to help you for a lot of these. Bulk extractor is good at finding track data though, because it does some of the validations we're going to talk about, but if it's encoded, it doesn't matter. So what are the steps in investigating and trying to find out how much track data we can confirm that the attacker had, or that we can at least dig up? Keep in mind the fines that the victim faces will be based probably on the entire exposure window of when the first system was hacked till when it was remediated. It doesn't matter how much you find. It's going to be however long they think they were hacked, and all the cards processed during the time should be deemed compromised. But our card brands and our clients want us to find out what we can and track down as much as they can, which is why we do this. So finding and decoding the track data is something that I don't have anything new to present to you for, but we're going to talk about anyway. And then going through the next couple steps are how we can improve upon the old ways. We can aggregate the data we find, remove duplicates, validate it, organize it, and generate statistics that are useful for everyone involved. So how do we find the track data if we can't do keyword searches? The most helpful thing is if it's an attack group you know about, like Raw POS or Carbonac or someone that you've seen in the past, any of the VIN groups that you may have heard about, you may know, oh, this is a specific malware family. I know what the file names are going to be. I know where they're going to write the output to. You can go find them easily. If you don't have that information, or if it's a new attack group, you might have to find the malware file itself, do some reverse engineering, find out, oh, this is writing it out to a specific file or a specific registry key, then you have to get that, and it's going to be a bit of more of a manual process, and you're also going to have to collect all this data, from all the systems that you have access to, all the systems they think they're stored on. An attacker may compromise one server in an organization and then deploy their POS malware out to all the locations, and from there they'll take the output files and collect it all back there. Great place to find tons and tons of output files. You may want to check there as well, and you may have to extract any interesting places that the credit card data is at. Attackers be stealthing. They're trying to be sneaky. They don't want Encase to find anything, which, not that hard to accomplish. But they may encode their data because they will hide it in, they will hide it in, sorry, wrong button, user error. They'll encode it, they'll XOR encode it, they'll base64 encode it, they'll use some keys for the XOR encoding that may be difficult to remove. I have seen incident response companies that they find the credit card output files and they don't know how to reverse engineer it. They say, I don't know what to do here. And they say, I guess we can't confirm any credit card data was actually stolen by the malware. And holy cow, like that's bold. So if that ever happens to you, please get a second opinion. But somebody's got to reverse engineer this process and help you with the decoding. I'm not an expert at that, so good luck. If you have any questions, I can try and help, but that's really depends on the malware family. So the old ways to do the next things we're going to talk about, you want to aggregate some files, right? You found an output file on every POS system. Maybe it made a new output file every hour or every day. You need to collect all these output files. Maybe you want to organize them by location. You found an aggregation server. You have all kinds of output files. How do you keep track of them? How do you, merge them together for processing? Do you process them all separately, or do you cat them all together? In the old days, we would cat them together, and that was it. And then you have duplicates, right? If I'm a repeat customer, I'll go back and I'll swipe my card several times. Do I want to count that as several lost card records? No, definitely not. We want to deduplicate that. We don't want to say that the more cards were stolen than actually were. If we have output files on the POS system and the aggregation server, we want to deduplicate that, so we don't have to worry about that either. In the past, we would run sort and unique Linux commands on these text files to take care of that. Again, nothing very exciting, and it was a lot of processing, a lot to do. We'd want to validate it. Are these cards real? Did the malware just randomly scrape some stuff that seemed to match the regex that was fake? There are a couple validations we can perform. There's a math algorithm called the Lund Algorithm, which we'll talk about in a minute, that most credit cards should comply to. We want to see if the brand matches a known brand, or if it's some random numbers, it probably won't match a brand. We want to see if the expiration date that was recorded there is valid. Is the month recorded 22? Probably not a valid track data record. If an attacker had that, they probably wouldn't be able to make a card to make fraudulent transactions with. And is the track data in a valid format? If it's just gobbledygook that doesn't look like anything, but we do have other real track data, we can probably filter that out as well. So the old method was a lot of custom stuff. We would have custom parsing scripts. We'd have to run the regex stuff by ourselves. Trying to calculate the brands and validate the expiration dates was really tricky. We had all kinds of custom Python scripts. When I first got into this, we would Google, hey, how do we do this? How do we do this? Like, is there anybody who's done this before? And I didn't find very much documentation or anything. So we were kind of making stuff as we went, which isn't standardized, isn't reviewed. There's no auditing. It was just kind of interesting. That's how we did that. And then you're trying to organize all these files, right? I have my encoded files. I decoded them. Now I have decoded versions of the files. Now I aggregated them, based on location. I catted them together. Now I have these aggregated files. I have deduplicated files where I've removed all the unique line, or I've just kept the unique lines. Then I've validated the ones that have that pass the Lund test. And I have to run brand validation. Then I have to run expiration date validation. All these files were just all over the place in different folders. And if you maybe forgot a step on a certain file, you didn't know. You had to take meticulous notes. It was a giant pain. And it was just really difficult to keep track of. Very tough. And then you want to calculate some statistics, right? The victim and the banks want to know, well, how many cards were stolen? We'd say, well, we have 50 primary account numbers that were found, but we actually have like 55 different primary account numbers and expiration date combinations. My Costco card just expired. They sent me a new one in the mail, and it had the same account number with a different expiration date. So now if I go back to a store and swipe it 1 month later, they have the same number with 2 expiration dates. People always get confused about how that happens. That's the best example I can have. Maybe a different authorized user would do the same thing if they have the same account number but an expiration date. That's what we want to keep track of. American Express or Discover calls and says, hey, how many of our cards were stolen? Well, we have to validate. We got to check some brands. These are some things we can find. We want to figure out, how many cards were found that the cards are still valid, right? If this hack started a year ago, the cards that were swiped a year ago may have expired since then. They may not be valid right now. I mean, they were still compromised, but they may not be valid right now. It is possible that, that people will swipe expired cards. First time I saw it, I said, man, that person must have been an idiot. And then 2 weeks later, I did it myself with a card I forgot I had. I swiped it, it got declined. I looked and said, oh, crap, now I'm that idiot. So please don't make fun of people if you see an expired card, because we can all do that, and I have done that. So please make fun of me if you feel the need to. But the old way to do this was with custom scripts. It was just whipping stuff together and seeing if it worked and hoping it did. So why do we have the new way? It was really difficult to keep track of what we were doing consistently. Very difficult for a third party to reproduce it. It was very difficult for a peer to review it. Very difficult to keep track of all these files without really meticulous notes and command line history. Difficult to deduplicate. And if you try and open this stuff in Excel, Excel only supports about 1,048,000 rows, which is, you may not think you'd ever hit that, but I have. So give me 1 second. I just have to get this next part ready, because we're going to, oh no, got an ad. We have the new way coming up. I want to introduce to you guys CDPO. That's my sweet Rasta horn sound effect. So the card data processor and organizer is the tool that I made that kind of helps deal with some of these problems. Again, I'm not claiming it to be 100% accurate. Please don't sue me if it's wrong, but it's a repeatable process that has been standardized. We can edit it if we find things are missing. It's open source, it can be reviewed. It's portable, all it requires is Python. Tried to even keep out any like Python dependencies where you have to pip install, because it's amazing. Every time I make a program that requires pip install, that my usage goes down to like 5% of people who should be using it. So we try to keep it easy to use. It's pretty secure. It encrypts the data in the database that it creates at rest, so that's good, although you will still have your clear text input data. It's flexible. We can combine stuff. We can create subsets of data. It's way faster than doing all the old stuff that we just talked about. So it's super fast, and it helps you stay organized, and it's relatively easy. So some of the features, it's all Python, Python 2.x or whatever, so no Python 3. You give it the input from your decoded raw track files, the things that you found them, you've decoded them. It'll run a regex to make sure that data is a track format. It'll run the Lund check. It'll do some simple brand matching. We'll talk about these. And it will do RC4 encryption because it's easy, fast, easy to implement. In theory, we could add a different encryption method in the future if people really want that. But it's just nice to have that in there. And you can pass the database around between your coworkers, and you can store stuff in the database. They can load it up with a password. It's nice. So here's the validations that it's going to do. This is the regular expression we're going to match on. We have, again, these green buttons. The blue part is looking for 12 to 19 numbers, starting with 1. I don't think any credit card numbers will start with 0, so we don't want to match on those. We can change that if needed. Then it'll look for the middle section, which is the equal sign or the caret name caret. Then it'll look for the next 4 digits, which are going to be the expiration date. You may notice that the security code and the discretionary data is missing. I don't really care about that. It doesn't help us track down how many cards were stolen. But PCI reports do want to know if that data was there. So you may want to do a manual verification to say, yes, it is there, or no, it's not there. But in order to keep track of how many numbers were needed, we don't need that information, so we don't include it. So how do we do the Lund algorithm? The Lund algorithm, which maybe you pronounce it Luhn, I've been told it's Lund. But it's a simple math algorithm where you like double some of the numbers, add them up, and mod it by the last number, and it has to equal 0 or something. It's relatively simple. There's the description from Wikipedia if you want to check it out, and a link. I know the text is small, but CDPO will check the primary account number for the Lund algorithm and see if it's valid. If it's not valid, we might want to assume that maybe the credit card malware was not so good, and it actually grabbed a random number before the pan. So it'll actually cut off the first one and try that and see, like if the 18 digits I grabbed weren't Lund valid, let's try the 17 digits. Let's try the 16, the 15, and it'll go until I think it hits 15. So it will do that. So just something to keep in mind. It'll also tell you if it's doing that. If it'll say, hey, like X number of lines didn't contain a Lund valid pan, but the substrings did contain pan. So just something you may want to validate, and we'll help you do that as well. Another question is, do all brands require Lund? As far as I know, all the really popular ones do, but Wikipedia told me that some don't. So we'll take a look at that right here. Dave, how do you do brand validation? You probably have some like really cool inside scoop with the card brands. Nope, I would use Wikipedia again. And Wikipedia says, hey, if the card number starts with these digits or these digits, it's this brand. So this is how CDPO does it. It does change, but man, is it way faster than doing it any other way or using a giant database. So this is what we have for now. Anything it doesn't recognize, we'll just put into an unknown category, which you can review manually yourself. I also suggest taking the data that we do process, and if you have, if you are talking to the card brands or to a specific bank saying, hey, can you please help us verify these and validate that these are actually the brands they belong to, they will probably be much more accurate, but no one's letting me into their secret sauce yet. I do have another slide coming up with some details. But again, this is Wikipedia, so you'll probably fail your research paper if you use this source. It's pretty fast. It's pretty good. But how it works, I guess I forgot to mention, is the first 1 to 8 digits of the primary account number are specific to a brand or a bank. So you can track that down this way. And then Wikipedia does have shows different lengths. So you could have 15 to 19 characters. And Lund validation, there's one that says not required or no validation. So it's in theory, some cards don't need the Lund, so C3PO or CDPO, wouldn't count those. So in the future, I have thought about, there's this website, binless.net, where you can just paste in, the first up to 8 digits of a primary account number, and it'll tell you the bank. So rather than, sending all of your data to this website, my goal was to just use their throttled API and scrape every single possible combination and create like a database or a range on your local system that you could query against, so you're not sending, compromised information to the internet. In theory, I've gotten it to work a little bit in the past, but it is throttled, so it takes a long time to build the database, especially if you want to go out to eight numbers of significance. You can say, just give me anything up to all the first 4 digits, but it's complicated. We're working on it. Another thing is if you do have access to a paid intel list, submit the account numbers to that intel list, and they can probably help you out. That's another thing that we do. Troubleshooting, you may come across a line that doesn't, shouldn't have been matched, or it's not matching something and you want to find out why. I'm in the process of making a script that will tell you, oh, this line didn't make it into CDPO and this is why, in case you're missing information that you would expect. These are the commands. They're here for reference. The basic is you'll import data into it. You'll be able to combine multiple collections. You'll query, create subsets. You'll show statistics. You can show detailed statistics. You can create a CSV of all the stats that are loaded in there, and you can write out the decrypted account information to a CSV, for providing to a victim or a bank. Let's take a look at a quick demo. So everything that's really important you should focus on is highlighted in red. Up top is just how you run it. If you just run cdpo.py as a Python script, it'll use a cdpo.sqlite database, or you can specify a database. In this example, someone sent me the SANS db.sqlite database. The next very important part is this nice ASCII art that you should all take a look at. I made that very it was very time intensive. I just typed that into some website that generated ASCII art for me. And then the third extremely important part is the license here that says no one's responsible for this. This is as is, although I keep talking bad about it, but I think it does work really well. But I just wanted to make sure you're all aware. And in case you're not aware, it'll then ask you, hey, are you sure you understand the terms and that you're not going to sue me? So you just have to put yes in there, or something that begins with Y. And then CDPO will say, hey, look, this database already exists. Do you want to delete it, make a new one with that name? Do you want to load it? Or do you want to keep that one and add another one with a timestamp as the name? So let's choose load. Okay, this is really cool. Now we're in the PCI track data relations command prompt. It's a nice Python feature that lets you just keeps looping for commands. So you'll be in here. You can run the help command to see all the commands we just talked about. I'm going to run the show command. That'll show me I have one loaded collection up here named patient 0 decoded. So I say, oh, okay, that's a lot of information. 855 unique primary account numbers. That's a good number of credit card numbers that could have ended up on the dark webs. It'll give you information about if we have track 1 only, track 2 only, if both tracks were recorded by the malware, and some of the brands that we matched. But I have all these other files I need to import. I have this patient 0 that my friend did, but I have systems 2, 3, and 4. I have a lot of data that I wanted to check out. So I'm going to run import, and I can just do a path here from my working directory input /system star. It'll use a wildcard there, which is pretty nice. And in this example, each of these had about 220-some thousand account number lines of track data that were imported in 78 to 87 seconds. So while you're watching it happen, it's slow, but I promise you that's really fast compared to what we used to have. This malware was also kind of inefficient. We have 2,653 unique lines did not contain track data based on a regex. A bunch of other lines didn't contain valid expiration dates. So it'll tell you if it notices errors like that we can help you track down. Okay, so I imported all of these files. Now I just want to lump everything together. I'll run combine all the files. I thought I made the text big, but I apologize if it's still way too small. So you can run one command and it'll say, hey, you have these collections loaded. Which ones do you want to add to the collection? Or you could just say all to throw them all in there. So this took about 90 seconds to run, and it ended up with 622,000 lines of unique PAN and expiration date combinations, primary account number and expiration date combinations. So that's a lot of track data. Now we're getting somewhere. So then you run the stat command, which will not only show you the same information you saw before with the show command, it'll show you the components that were loaded in there. So as you're combining and organizing these files, you can keep track of which files you loaded together. So when you say, how did you create this collection? You don't have to remember, oh, I don't know what information that came from. And then the stat command will also show you expiration date counts based on year and month. So this is an example. For 2016, we had 44,221 cards that expired in that year, and then it's broken down by month there, 6 in January, 11 in February, and so on. So kind of useful, always interesting to see where it goes. If we run a query all the files command, we can query specific data out of there. We can say, I want to find I only want to see the track data that fits a specific expiration date range. For here, I chose greater than or less than with the G option. Then I said 1706, which is 2017 June. So all the cards that are valid are either expiring or still valid as of this month. Then it'll ask what brands I want. I chose American Express. Maybe they're knocking at the door. They want to know which data of theirs was stolen, and they only want to know data that was stolen that had both tracks. Why? I don't know, but the option's there. So we choose that, and it got less than 22,000 results. So that's very useful. We can then add that into its own collection so that we can run stats and combine it again some more. But then I'm going to run the command file mx report, which is going to then write all that decrypted information to a file. And then I'll run the CSV stats command, which is going to generate a CSV that we'll look at with all the stats of everything we have loaded in. So I'll check my file system. There's amex report.csv. Not going to show you an example of that file, unfortunately, here in a public setting. But then we have a CDPO stats with a timestamp.csv, which looks like this. All the information we have loaded in, how many counts of primary account numbers we have, and their expiration dates, how many records had track 1 only, track 2 only, both tracks, the expiration dates, which is a terrible JSON format because that was really difficult to fit into Excel, so that's what we're stuck with for right now. And then an overview of what all the brands look like, and you'll be able to see that some brands are more popular than others, as you may expect. And when we run the statistics command, it'll show us the query that we ran, so we know exactly how we created this, queried collection. And when you leave, it'll give you a motivational blue ribbon that says you're the best, because ASCII art is very important. When you do stuff like this, we want you to feel happy and empowered because you just did something really, really cool. So hopefully the blue ribbon helps, and I appreciate that. So that's our live PowerPoint demo. You can download this from my GitHub. In the future, would like to add a couple more commands to do a little bit more manipulation. Tab completion, all those commands you saw there is no tab completion right now. We have some combination speed improvements, maybe stronger encryption, maybe the binless post-processing we talked about. Things to watch out for. If the victim is using format-preserving encryption that maybe the data is tokenized, but it still fits the track data format, it may even still pass the Lund algorithm. CDPO doesn't care. It'll just process it as normal data, so watch out for that. You may have store cards or gift cards that have maybe don't need the Lund algorithm, or they have their own custom IIN or BIN numbers. And I don't know what chip and pin and chip and sig data looks like in memory. So if anybody knows, let me know, but I haven't seen any malware scraping that stuff out, and I don't know if it's our normal track data formats. I'd like to shout out to Patrick Charbonneau, who helped implement the RC4 encryption, Jay Taylor, a friend of mine, who helped me figure out the old ways and how we did it and why we need the new ways, and Brandon Schondorfer, who's working on a cool SQL query to have more speed. So standardized, not perfect. All right, summary, it's standardized, it's fast, there's features, it's expandable, and it's not perfect, but I mean, it's reproducible and better than what we have before. So if you get to use it and have any questions, just please let me know or generate an issue or feature request, and that's it.